All right, so in lesson 3.2, we're going to look at kind of the same naming part, but what happens when it's parallel lines that are cut by a transversal? Well, that creates the corresponding angles postulate. So two parallel lines cut by a transversal, then all the pair of corresponding angles are congruent. So kind of those relationships that we see. So let's go ahead and take a look at this example down below here. So if we know that this one, 11, is 51 degrees, then we're going to go ahead and find the other measures. And the first one is the measure of angle 10 here. So what is 10? Well, it's next to 51 that forms a line. So this one would have to be 129 because they add up to 180 because they're a linear pair. So that's kind of what we're using there to help us, because it's a linear pair to 11. The next one is going to be angle 12. So that we know is also going to be 51 because it's vertical. Okay. Next one is going to be 13. So 13, again, you can use linear pair to help you, or vertical to angle 10, which we already know. So that's 129. So either linear pair or vertical. All right, the next is going to be number 14, and 14 is right here, which we can say, so that is going to have to be 129, and that relationship to 13, it's going to be the same because those are alternate interior. All right, the next one is going to be 15, and we could say that that one is 51. We know it's 51 corresponding to 11, or could use a lot of relationships as we get to more. I don't know if we're continuing to relate it back to our angle 11, but we'll do it on this one corresponding. Okay. And then 16. 16 in relationship to angle 11 is 51 because those are alternate exterior. And then our last one is going to be 17, and that has to be 129. You could use vertical, you could use linear pair, either one of those. Vertical to angle 14. All right. So, by the alternate interior angles theorem, if two parallel lines cut by a transversal, then we know that those alternate interior angles are congruent. So, 1 and 3 and 4 and 2 are going to be congruent. We also know that our same side interior angles are going to be supplementary. So angle 1 and angle 2 add up to 180, and 3 and 4 are supplementary. So they also are going to be adding up to 180. Then we know our alternate exterior angles are congruent. Okay, so basically they're either congruent, or if they're on the same side, kind of next to each other, then we know they're supplementary. So let's go ahead and apply some of those rules to some pictures down here. So we got floor tiles in Michelle's house. It looks like angle 2 right here is 125. So let's go ahead and put that in the picture. We want to find the angle 3. So what is this angle? Well, those are alternate interior. So we can say that angle 3 is 125 because these are parallel. Alternate interior angles theorem. Okay, now we're going to take a look down here at this example where we have the measure of angle 5, we have the measure of angle 7. So these are in the same position, so they're corresponding, which means with these lines being parallel that these are the same. So we know that the measure of angle 5 and 7 are equal. So 2x minus 10 is equal to x plus 15. And then we can go ahead and solve. So x minus 10 is equal to 15, and so x is equal to 25. Now, the measure of angle 4 compared to the measure of angle 8, those, well, 4 would be the same as this one right here, which would be supplementary to 8. So that one is going to have to add up to 180 because this one is going to be the same as angle 4 right here. So it would be supplementary to 8. So 4 and then times y minus 5 plus 4y is equal to 180. So 4y equals, or 4y, minus 100 plus 4y is equal to 180. So that's going to give me 8y minus 100 equal to 180, and then we'll add 180. So 8y is equal to, we're adding 100, so that's 280, and then divide by 8. And we get y equals 70. All right, and then this last relationship here is going to be 4 and 5. So 4 and 5. So these, what is that relationship? Alternate exterior, which means they're going to be congruent. So put off to the side alternate exterior. So 5x minus 12 is going to be equal to 3x plus 16. And let's go ahead and subtract the smaller x. So 2x minus 12 equals 16. We're going to add 12. 2x is equal to 28, and so that means that x equals 14. All right, so this next one, if we look at its relationship, we're going to figure out how many other angles have a measure of 100, and we're going to name them. So if this is 100, then we know that it's alternate interior, so angle 2 is 100, or angle ABK, but it's written in there, we can just use its number. 100, let's see what else would be 100. Well, we would know this one, I don't know this end piece, but if I had a piece here, then I could say LK and then something, but I don't really have that one, so that's all right. If 2 is 100, then this angle right here would also be 100. So DEF, that would be 100. This one, alternate interior right here would be, so LHJ. Okay, there's that one. This one right here, so EHG, that's 100. BEH. Okay, and maybe CBE. Those would all be 100. Okay. All right, so looking down here, we're going to use the property of parallel lines to find x. Well, this is going to have to equal this because those are corresponding. They're in the same position. So 4x plus 22 is going to equal 5x. So then we can go ahead and solve. So x has to equal 22. That's pretty short. Next, we're going to use the property of parallel lines to find the value of x. So if we know that this is 70, we know alternate interior, that's 70. And then together, this all forms a line. So that would mean that these two angles are 110. So we could set up kind of an equation with x plus x minus 8 equals 110. So that's 2x minus 8. And then we can add 8. And then x is equal to 59. All right, taking a look down here, if we've got parallel lines, let's look for some relationships of some angles that we have here. It looks like with these being parallel and this transversal, that this kind of cutting through, that this one and this one would be equal, and it looks like this one and this one would be equal because those would be corresponding. So we have 5x plus 4y equals 55. And then down here we have 5x plus 5y equals 60. So it looks like we have a system, x and y. So if we can go ahead and get something to cancel, we could solve. So let's make this, multiply this by -1, each thing. And now we can go ahead and add vertically. -y equals -5. So if y equals 5, we could plug it back in to one of these equations, maybe the top one there, 5x plus 4 times 5 equals 55. Subtract 20. So 5x equals 35, so x equals 7, and y equals 5. All right. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. That is a theorem. The next is going to be if we use the property of parallel and perpendicular lines, we can find the value of x for this kind of artsy mosaic piece here. So let's take a look then. This would have to be adding up to form a right angle. So 65 subtracted from 90 is going to give you 25. And that's going to give you 25 here. So angle B is 25. And then these two together forming that right angle. So A is going to have to equal 50.